One of the great problems we have with our private key is we can't prove we control it. And so when we write a message to a chain, we don't know that the data that we wrote is actually the data that gets recorded because we can't prove that we used our private key. Somebody might have stolen it. So a chain is censorship proof and trustless as an immutable ledger, but we can't prove that the data written on the chain was intended. That's a huge challenge in this process, because intended data is important for us to make assumptions about how we're going to manage systems and how much money we have and all the different parts. So we believe at Rivets that there's an opportunity to expand the use of the chain to incorporate cybersecurity controls that will allow us to prove the transaction was intended. So today we have this concept of a transaction hash. We can look at the chain, we can see the transaction hash. What we're doing is adding to that transaction hash this concept of an attestation hash, which comes from the environment that wrote the transaction. So we leverage the trusted execution environment inside a device, this is already in the hardware, to secure that private key. Now, why is this important? Because this is important, it adds value to the data that we write to the chain. Because now we can store on chain not only proof this transaction was executed, but also evidence that this device in this condition with these controls wrote this transaction. Now, trusted computing is already in hundreds of millions of devices. It includes not only security within the processor to hide and process secrets, but capabilities like secure display. So what we see on the screen is what we're going to sign, and trusted input so we can properly collect that the user intends for this transaction to happen, whether it's biometrics or secure PIN. So what we've done is we've allowed this trusted execution in the device, inside the device, to reach out to the network and include information from external controls. That's what we use our Rivets token for, to pay for the device accessing these external controls and pay for those services. And we can now incorporate that proof of control into the forensic claims that are possible on the transaction. So we can prove that this device in this condition with these controls actually performed that instruction. So we're in the early stages of the development of these capabilities. We provide a set of developer tools that any third-party application developer can use to incorporate it into their project. And we provide a new business model in the form of a token so that anyone can provide a third-party control. This is how we replace this voyeurism model of network security and instead have a trust agent in the device ask, tell me about the condition I'm in, tell me where I am, tell me, am I in the building, are you badged in? I don't mind if my device collects that information. Well, that's an interesting process that now I've collected this information around the device. I can now use that to prove the intent of the transaction. And so this is a really important piece of the puzzle. With chains, we have an immutable ledger, but we need to assure, they're going to run my slides again, aren't they? They need to assure that the transactions that we write are the transactions we intend. And that what's important as you build a project, as you think about these capabilities, as you look at projects, the real question is, what can they prove on their chain? If all I have is the chain, I don't want to have my Microsoft antivirus log files helping me to determine whether or not my machine was in the right condition. I want to be able to actually incorporate real mathematical proofs as part of the transactions. And so cybersecurity is an interesting piece of the puzzle. It wasn't built into blockchain to begin with. It's very hard to prove that we wrote specific data to a ledger, and it's even harder actually to read a ledger and get the data off and trust that the data we got off the chain really came from a chain. And so Rivets is focused on leveraging the trusted computing standards, the industry standards around hardware security, to help construct those mathematical models and some of the minor changes that need to be made in blockchain projects to associate very strong cybersecurity controls to improve the quality and value of the data that we can store on the chain. So we launched a token to do it. We think we're a really great example of a utility token. And thank you for your time, and I hope that if you have any questions, we have a booth out there. You can come find out more information about our project. Thank you very much.
Thanks very much, Stephen. So we're going now from the future of decentralization to now the future of